Today we will be learning about the properties of linear equations and how to graph them easily. Linear functions can simply be described as functions that form a line when graphed, and the simplest form of this equation is called the parent equation. And for linear equations, the parent equation is y equals x, so it's basically just a simple relationship between y, which is the output, and x, which is an input. And so to graph this equation, we need to create an xy table, which is a table in which you essentially plug in an input and you use your equation to get an output for it. So in our xy table, let's plug in the input values, -2, -1, 0, 1, and 2. And since our equation states that y is equal to x, our y values, our outputs, will be equal to our inputs. So in this case, for y, we would also plug in -2, -1, 0, 1, and 2. So now that we have all of our inputs and outputs, we'll be able to graph this equation. So since to graphing this equation using the xy table is pretty simple. So to graph the first point, which is x is equal to -2 and y equals -2, we would simply start at the origin and go to the left -2 on the x-axis, go to the left 2 on the x-axis for the x equals -2, and go down 2 on the y-axis for y equals -2. And once we do this, we would create a point at the place where these two places meet, which would be right here. And for the next next set of coordinates, x equals -1, y equals -1, we do the same thing. We go left 1 and down 1. And by following this pattern, we can graph the remaining points in our xy table, and we can essentially, and now that we have all these points, we can connect them and create a line, like the one right here. So the graph of the parent equation of a linear function is called the parent graph, and this is basically the original graph, and this is the graph that all other more complex linear functions are based off of. However, as linear functions become more and more complex, this equation y equals x has many variations to it, and in order to graph these more complex values, we use a different type of equation called the general equation. And the general equation for a linear function is y equals mx plus b. So in this equation, y and x are once again our input and output values, and they are also called variables, which means that they change many times throughout the equation. They can be replaced with a number of different numbers. And m and b are called constants, which are numbers that essentially stay the same throughout the equation and never change. And in addition to being constants, m and b are also very important in another way. B is the y-intercept, and the y-intercept is basically the point where the graph intersects with the y-axis. And the slope is m, and the slope is basically the thing on the graph that controls how steep it is and which direction it points. And the way we use slope in a graph is by using rise over run. So for this example, let's say that my slope is 1/2. I have a slope of 1/2. If my slope is 1/2, the 1, which is on top, would be the rise, and the 2 would be the run. And rise is essentially how many points that you go up for each equation for each point, and 2 is how many times you go to the right or left. So for a quick example, let's say that I had a point right here, and I wanted to graph a line with a slope of 1/2. So to do this, I would have to start by going up 1 and going to the right 2. And by doing this, I would draw a point at the spot where this meets. I would connect the lines, or connect the dots to create a straight line. And using our knowledge of slope and y-intercept, it becomes very easy to graph more complex linear functions. So now we know how to do this. Let's graph a sample equation. So the equation we'll graph as a sample is y equals 2x plus 1. So to start this equation off, let's start out at the y-intercept, since that's the point that we know for sure is going to be included on the graph. So since b, or our y-intercept, is 1, we know that we have to go up 1 on the y-axis. So let's go up 1 on the y-axis and form a point right there. So from this point, we can graph all of our other points by using the slope. And by doing this, we'll use rise over 1, like I stated earlier. So since our slope is 2, we can rewrite this as a fraction, which would be 2 over 1. 2 being the rise, and 1 being the run. So, to graph our next points, we go up 2 and over 1. To graph this point right here, and right here. And we also go down 2 into the left 1 to graph our second point. I apologize, right here. And once we have these points, we are able to connect them to create a line. And so now that we succeeded in creating this line for this equation, let's create an XY table just to make sure that we did this right. So for our XY table, let's do the same thing we did before and plug in -2, -1, 0, 1, and 2. So this is a little bit more tricky since we actually have a more complex equation. So for our first value, -2, let's plug it into our equation. If we change the x in this equation to -2, we'll multiply -2 times 2 and get -4. And adding 1 to -4 will give us -3 for our output. If we use -1 as x, we'll get -2. And if we add 1 to that, we will get -1 as our output. For 0, we will get an output of 1. For 1, we will get an output of 3. And for 2, we'll get an output of 5. So now that we have our outputs, let's check our graph to make sure that we have these points included on our graph. So the first point would be -2, -3. And this point would be right here on the graph. We didn't exactly draw all the points we could, but had we completed it, it would be right here. And this is on the same axis as our line, so had we continued our line, this point would have been on our graph. And another point the next point that we have is -1, -1. And this can be seen on our graph right here. So that's -1, -1. Another point that we have is 0, 1, which can be seen on our graph right here, which is our y-intercept. And finally, our last point that we have is 1, 3, which can be seen right here. So this proves that we did, in fact, successfully graph this equation because it includes all the points that it should from our XY table. And now that you understand how a linear equation works and what its different functions are and how it can easily be shifted, graphing other equations should be quite easy. You should have no problem graphing more difficult linear functions. So that concludes today's lesson. Thank you for listening.